for such a warm introduction. And again, I welcome all the participants to this subject-specific tool session that we are taking in SRG. So today's topic is chemistry, and the tool that we are going to use here is Argus Lab. So just I want to tell here that today's session we will teach chemistry, but with a twist, I can say, because unlike like just going through the 2D diagrams and just reading about the molecule, here we will be entering into a very fascinating world of molecular modeling, I can say, where you will visualize the structures, you will visualize the bonds. You can basically we are entering into the molecule because just giving a 2D representation to our students, sometimes many abstract concepts are left behind. They are not attended properly, and the student they want to relate it. They want to see how the molecular interactions are happening. So in today's session, I'm going to take you all through this journey through the Argus Lab tool. So let me start with my presentation. So here you can see on your screen that why I have mentioned that integration of technology in teaching learning. So even if we see that our national education policy NEP 2020, it put lot of emphasis on the usage of digital tools in our teaching learning process so that we can enhance the overall process and all the students they have a they basically they can easily relate with that particular concept. Just I mentioned in the beginning, especially in the chemistry, there are many abstract concept which need certain kind of visualization. So we need to provide our student through different medium all those kind of platform so that they can easily understand any complex topic. So in our CIT, as per various initiatives have already been taken, and you can see on the screen, like Diksha is our national digital repository containing large number of e-content. And there are various educational apps and tools also, like there's an app, e-Pathshala, Jadui Pitara, that is catering to diverse learners. So in particular, in that context, I can say this technology, it is basically acting as a catalyst for the enhancement of for the enhancement for enhancing the actual teaching learning process across all the levels. So going further, so can you all see my screen? It's visible. So now, can you see this slide now? Interactive tools in chemistry, yes. So just I mentioned that we have to use digital tools in our teaching learning process. So in chemistry, because today's subject area is chemistry, so you can see on your screen, there are many digital tools available, and mostly all of them are freely available, which I have listed here. So you can easily download and explore all these tools with, I have shared the download with the link is also attached through which you can easily access. So I'll just quickly read out the name so that you can easily remember them, and in future also you can explore. And why I'm listing all these software here, because in our previous SRG programs, some kind of hands-on session have already given on these tools. So I'm not going, so that's why I have chosen a different topic. And there are other reasons also for choosing the virtual lab, which you will be, I will address later on. So first is the Argus lab. So here you can see this Argus lab. So I'll show through this because there is certain kind of animation. It is not playing. Let me try. Okay, it's coming. So first is the Avogadro. So Avogadro is a molecular editor and 3D visualization tool. And there is a JMOL. JMOL is Java Mol. It is molecular viewer of 3D structure. Then there is a Calcium. This is basically help in exploring the properties of the elements present in our periodic table. And ChemSketch is another freely available software for drawing chemical structures. And there is a T-table. Again, it is similar like to the Calcium with some advanced feature. Now, what we are going to do today. Can you see? I have clicked now Argus. This is an Argus lab. Can you all see this? Yes. So this is the tool that I have chosen for today's session. And it has, I can say, more advanced feature, and it gives better result. If I compare the data with the experimental values, it has more reliable results that come out. So coming to the next part, so I'll quickly take you through the brief points about the Argus lab. We will not go much detail. I'll take you directly to the Argus Lab software. So just what is Argus Lab? Just I told you it is a 3D molecular modeling software through which you can build any 3D molecular structure, and you can do a thorough analysis of any chemical structure. Okay, there are measurement tools available here. What does it mean? Measurement tool. Measurement tools means there will be many uh, uh, tools like available. There will be available for calculating the bond length, bond angle, even energy you can calculate. There will be feature for optimizing these structures, and there are many advanced features. If you want to even take your study further, you because the feature which I am going to discuss today, that they are limited to your class 12 curriculum. You can take it further if you want to. Let us suppose you want to do some kind of research. You can use those tools and advanced feature of these Argus Lab. Even if there are some, I will tell you at the end what other advanced features are available that you can use for your own study, for your own research. So for during the session, I'll strictly limit myself, like as a school teacher, as a school educator, what how you are going to use this software to deliver good content, to explain any concept to your student. So next point is the carbon chemistry. Inside you have a detailed analysis, and just I mentioned there will be a molecular interaction analysis. This molecular interaction analysis is very helpful when we deal with any chemical structure, because sometimes there are many reactions. You want to go inside, you want to study about the reaction pathway, you want to visualize how the reaction is happening through various data. It is not always necessary that you have to go inside the molecule, then only you will understand the molecule. Here, what does it mean? I mean, you can calculate certain parameter, certain properties on basis of which you can interpret. So that kind of interpretation, for that kind of interpretation, you need data. So that data can be fetched easily through this Argus lab. So coming to the next point, that is, what is the pedagogic value of this software? Because we have to ensure that whatever we are using in our classroom teaching, it is well aligned with our curriculum, and we are and the student can easily understand also. So first of all, it facilitates teacher-student collaboration. I will tell you how you can even, I will show you one assignment that I have created, and you can also give to that your student after demonstrating the Argus Lab software, so that after once that assignment, you can ask your student to complete that assignment through Argus Lab. Then later on, you can have a interaction with your student. They can come up with their feedback and their proper analysis. So at that time, the teacher plays a very important role in making the learner or the student understand those concepts, because just taking out the data is not sufficient. We should be able to interpret all those data. We should be able to do the thorough analysis. For that, as a teacher, you can guide your student. Then again, there will be enhanced molecular understanding. Just I mentioned, many measurement tools are there. You can calculate dipole moments. You can, because if you are talking about like simple molecule, we generally tell like there is a water molecule, its dipole moment is this. Sometimes just if we make the student understand through certain kind of visualization, we allow him to draw the molecule on their own and calculate that dipole moment, then they found it very fascinating, And those things will be remembered for a long period of time, I can say, because they have visualized the thing. Then there is a integration there is a, just I mentioned 3D molecular view is very better, very good of this Argus lab. Then coming to the next, because whenever we use any software, it is not like any software has, it is it is completely, I can say we can rely. There are certain limitations always associated with each and every software. No software can be complete in itself. I can't say that no other software which I mentioned earlier, they are not good. It is not like that. Each and every software has their own limitation, has their own strength. Even when we publish any paper, any article, as a teacher, as an educator, we also refer certain documents, certain software. Sometimes we calculate certain, we obtain result from one particular technique. Sometimes we merge our computational study with theoretical study. So all these kind of arrangement we have to do. So first of all, coming to the strength, it is freely available without any cost. You can easily access this. Simple to use, very simple interface is available, user friendly. And just I mentioned, it will facilitate a better comprehension of molecular structure. And there will be best feature is that there will be on-screen facility with a library covering all the periodic table elements. So let us suppose you are a new user. You don't understand how to draw molecule initially. So there are some inbuilt structures also. You can easily take those structures, procure those structure from the inbuilt library, and you can start exploring your molecule. So that way also it can be done. But once you are thorough with that software, then you don't need to procure your molecule from inbuilt library. You can easily build a molecule within fraction of second, I can say. And there is a flexible output option. It is not just limited to like you will get the document in just in one kind of format. You can see, you can easily get your data in different kind of format. It's listed, you can export the images also. The best part is you can easily take out the images and save your images and easily paste your images. You want to present some PowerPoint presentation, you want to show some kind of 3D molecular structure, you can easily take out that, because it is a reliable medium. Because simply sometimes what we do, we want to have some kind of molecular structure, we simply Google and take the molecule picture. But it is not good way, because once if you are you understand any software, I would recommend you build your own molecule, specify the geometry, and you can easily uh, download that molecule and use for your reference. Then coming to the constraint, its language limitation is that the menu and the content which is listed, it is in English. That is one limitation. But once you will go through I'll take you through that interface, you will find it there very, you can easily understand those terminology. It is not something very difficult. Then there is a functional limitation and some kind of compatibility, only compatible with Windows OS. So these certain limitation I can say. So we have, despite of all the limitation, I can say you can get good result with this software. And there is a downloadable link is given here. But instead of downloading directly from this, I would suggest, may I ask,
हेलो।
have you gone through the
तो क्या
downloadable?
करूं यार, जहाँ एक बंदे कम थे वैसे थोड़ा सा ठीक है।
May I ask you, like, did you go through the video that I shared in SRG WhatsApp group? How to download this
हेलो।
Argus lab? If not, still I'll play for you during this session so that you can download it easily. Then going further, so let me show you what kind of interface you will see. So here you can see on the left hand side, there is a screen where you have to draw molecule. Okay. And then after drawing molecule, you can see on the right hand side, this kind of structure you can get. Since I have drawn benzene, so this kind of visualization you can see. Then these are the various tool icons which are available here. You can see. So mostly I will cover in today's session only. So coming to how to build the molecule, how you can build this molecule. So there are various steps I have listed there, which you can refer later on. So I will not read out all those steps. It is of for your reference, for future reference. I will demonstrate each and every step through Argus Lab only. Then going further, all the steps I have listed, which you can go through easily after building your own molecule. So one thing I want to show you to everyone, even if you have a query, you can raise your hand. We will take up the query. So here you can see, like I have built one molecule on the left-hand side. You can see it is a water molecule. So after see what kind of transition is going here. There is a clean geometry and there is a optimized geometry. So you can see the molecule, the optimized geometry is the most stable structure that I have obtained of water molecule, and how I got it, I will show you through Argus Lab. Now, this is our first hands-on exercise that we have to do. So in order to do the hands-on exercise, I request all of you to download the Argus Lab. So are you able to download, or you want me to show the steps for downloading? Please tell me.
Ma'am, in desktop, in laptop, we have to download.
Yes, sir. It will. Yes, sir.
The link is given in the group. WhatsApp.
Sir, I have shared one video how to download. So if you want, I can share it here again.
The link. Yes, ma'am.
Sir, is my screen visible? The video link is visible? The video that I was showing?
No, ma'am.
Okay, let me share again, sir. So see, sir, this is the video. Can you see it now?
Yes, Argus Lab. Yes, ma'am.
So this is the link which I have already shared. So what you are going to do, you have to type Argus Lab on your Google. So see, this kind of page will come. Okay. So what I have done here, I have just click on this downloadable Argus Lab. Zip file will be there. Then you will click on your zip file. Setup pe click karna hai. After this setup clicking, this kind of window will come. You have to click, you have to accept the license agreement, then next, and going to next. And this way, you can see, you can finish downloading your Argus Lab. And after that, this kind of icon will appear on your desktop. And this will be the window interface of the Argus Lab. Okay, sir. So okay, I think now I can we can start with our hands-on session. Okay, you can download it in the meantime. So let me share my screen, which I mentioned. So I have already downloaded Argus Lab on my screen. So here you can see the Argus Lab window. Is it visible to everyone?
Yes, ma'am.
Okay. So here you can see this kind of, initially it will be gray. So what we have to draw the molecule. So for that, here you can see there is a file button. Here you can see. Okay. So I'll click on that. And after clicking, create new molecule kind of window. This is a window for drawing our structure. So here, when I click, you can see this kind of arrow mark is there. So how we can get rid of this? I will simply left click. I am using my left click mouse. Okay. So I'll click on this yellow arrow and I can simply get rid of this kind of arrow anytime during the screen. So let me build my molecule. So here you can see there is a add item. There is a pencil icon with a atom. So we can add the atom one by one, and there is a builder toolkit. So builder toolkit, basically once I click on this builder toolkit, this kind of dialog box will appear. So here you can see all the inbuilt atoms are present here. Inbuilt library is there. There is an atom. You can see, you can click more atoms will come, and you can easily select what kind of atom you want. You can specify the geometry also here. And there is rings, cyclohexane, some benzene ring, all these, and the even amino acids you can maintain. There is a polypeptide builder also. You can create your chain also here. So this way, even bigger complex biomolecules can also be created through this Argus lab. So see, I have selected this selection tool. This is called selection tool. So how to drop the atom? First step is you have to drop your atom on this black screen. So how you will do? I will do right click. Okay, right click. I have done. So after right clicking, you can see I want to get rid of this kind of arrow. So I have just click on this yellow. So by default, Argus lab, every time whenever you select any atom, it will take carbon. It is a by default setting, but we can change it. So let us suppose how to change it. Just make sure every time whenever you are making any selection during the Argus lab, during building any molecule, you have to use your left click. You have to do left click mouse. Okay. So here I have done left clicking. So you can see it is highlighted now. Okay. So after that, what you will do, I will do right click. So for left click is used for first selecting that particular atom that you want to select. So that will basically highlight that particular portion. Then what I did the right click. Okay. So after right clicking, the dialog box has come. Now I can easily change my atom also like this, or I can initially took the atom from the library also. So both ways it work. Okay. So let us suppose I change this atom to the first of all, I'll draw hydrogen molecule for you. So let me change it to hydrogen. So again, it is giving me an option. किस तरह का हाइड्रोजन चाहिए? It should be simply hydrogen, or it should be na bridge form, जो हमारा diborane में होता है. I'm sure I don't want diborane wala hydrogen, so I simply click hydrogen. So watch closely. It has changed to white, because there are certain color coding which have already been universal color coding that we say. So for hydrogen, we use white. Okay. But again, it is not mandatory. We know this thing, but universally everyone is using in that way. So we are using, still it gives us option. We can change the color also. So now I have chosen my hydrogen. Now next, again, I want to have one more hydrogen. Again, I will select the add atom. I have clicked. Now see, again, I will drop my atom by doing right click. So again, by default, it will take the carbon for me. So what again I will do? Again, I will select and change this. I will do hydrogen. So here you can see now I have two small hydrogen atom balls are here. So how can we now next step is that I want to create a bond between them. Okay. So how you can do you can see on the menu bar, and the best part is that even if it is for every icon, if you hover, so certain kind of mention, some caption will be there, like for which purpose this tool can be used. Again, it is helpful. So let us suppose it is giving me automatic bond on and off. So I have clicked on that. So what I'll do, मेरे को जहां पर भी बॉन्ड बनाना है मुझे उन एटम्स को सेलेक्ट करना पड़ेगा. So let us suppose I'll click. I have chosen this, and I will choose the next atom. So now you can see the bond has been formed between two hydrogen atoms. Now this way I have done this. Now next step is even you can label your atoms. So labeling can be done by clicking on label here. So all atoms. So I'll click on all atoms. So it will show me. Okay, let me make it more zoom, bigger size. How we can do that? You can see there is an option. I can project my molecule in the center of this window. So it will project this like this. Okay, so this way you can see now. Now I have labeled, and other kind of labeling is also possible. I can label, I will go all at atom, all label setting. Even I can label the hybridization also. Let us suppose student has chosen the wrong hydrogen atom here while building. He has chosen. So as a teacher, you can easily figure out, because when you will assign your student to draw hydrogen molecule, so it could be possible that he will pick a different kind of geometry of hydrogen while making hydrogen molecule. Instead of picking simple hydrogen, he could have chosen a bridge hydrogen atom also. So you will specify the hybridization. It will give you clear picture. It is SS. So it is clear. Hybridization is also, you can see, you can easily even show atom number and symbol you can show. Other kind of labeling are also there. Atom names can be given. Formal charge can be, we can know what kind of formal charge is there. So different kind of labels, even like in molecules, organic molecules, chiral center we want to define, we can do that also. So there are various kind of options as per the different molecules. So let me deselect this. I can even remove all labels. Okay. So next step is that now, uh, just one more thing I will want to tell. Let us suppose now your student has drawn this molecule and your student has come up. Now, sir, and ma'am, this is the molecule which I have built. So first of all, you will ask your student what is the bond length in order to check whether he has correctly built or not. So how you can do that? I have simply, again, I am using every time the left click mouse. So I have done the left click mouse and you can see, I will do again. It is a single bond. We know. Then there is a bond info. I'll go on the bond info and you can see it is showing me 2.6430 Armstrong, the bond length. As an educator, you know, this is not the actual bond length of hydrogen. In the HH bond length is not the perfect bond length. So why is it so? Because we have drawn this molecule as a layman. Some हो सकता है मैंने bond बनाते वक्त I have not considered, taken into the account all the parameters, all the I have just roughly drawn this. So how can we get the accurate structure? So for that we have to do the cleaning of your structure first. So you can see the scissor kind of, this kind of icon here. This is for cleaning geometry. So what clean geometry will do? It will clean your molecule. Again, it will not give you the most stable structure. It will clean geometry means your structure will be in the close proximity with the actual structure. उसको बहुत आसपास ले आएगा, but अभी भी वो accurate तक नहीं पहुंचाएगा. It in close proximity. So watch it carefully how I am doing it. I will click on this icon, and once I'll click, you will see that the bonds, they will compressed. They will try to compress. So let me clean it. So before cleaning your geometry, you have to save your molecule also. So see here, I am clicking on cleaning geometry. It is asking me to save this molecule first. So let us suppose I am saving this molecule on my desktop, and I'll name it as hydrogen molecule. Okay, I have saved it. Now see, after saving, you can see how the bonds have come closer to each other. Earlier it was so elongated. Now it has come closer. So this way we have cleaned the structure, but still it is not the, I can say it is not the accurate structure. For accurate structure, you have to optimize your structure. You have to optimize your structure. So for that, what we will do, we will go to the calculation part here, and there is an optimized geometry feature. Okay. So I'll click on the optimized geometry. So see, Don't get confused with this dialog box. Again, I'm telling you, for like, if when you making your student learn this software, don't uh, uh, try to make them understand that all these, again, I'm telling you, it is used for advanced study also, this software. But I am telling you from your, as a teacher perspective, from a school's educator, how you can use, align it. So all these are the various kind of models, like quantum mechanical, molecular mechanical. These are basically different kind of area. So I'm not going to focus. So what we are going to, these are basically basis sets. When we do computational molecular modeling, we have to define basis sets. So I will not go much detail into that because this is a completely different area. So by default, I will choose PM3. Okay, this is the basic basis set that runs, that gives good result. So I have chosen this molecule. For smaller molecule, PM3 gives best result. So I have chosen, even AM1 will also give best result. So here you can see different kind of, even we will not go into detail. What we will do, we will calculate properties. So you can assign what kind of property you want to calculate. Let us suppose I want to calculate dipole moment. I have checked that box. I want dipole moment in my result. I want bond order. Even it will calculate bond order. It will calculate other parameter also. So let me click on the OK. So when I click OK, so you will just watch carefully. After you can see on your screen, like after, when this black screen is breaking out, there is a white color of screen. So once I run this calculation, some kind of calculation will go so fast because it is a very small molecule and it will take just, I can say, within 0.02 seconds. It will not take any long time. So let me click on OK and I'll run this calculation. So here you can see it has been completed. Now, how can I can see my result. So you can see there is some kind of document notepad kind of icon here. I'll click on this option. So here you can see the output file has been generated here. Okay. So you can calculate, you can read, you can take out your data from here easily. So I'll read some data for you, which we have tried to calculate through this. So here you can see the atomic information. We will not go. What we give remark to this, see, these are the bonds it is giving. We try to calculate the, let us suppose, see, this is the total energy in kilocal per mole it has calculated. The energy of the heat of formation has been calculated for this. Okay. So this way you can calculate heat of formation and other parameter also. So this way we can we can get the entire, whatever property we want to calculate, we can easily get from this. Now, after this, even initially we got some different value. Now we'll check again through this structure. What is the bond length? Again, I'll click on this bond and I'll calculate the bond info, and you can see how much is the difference. Can you see now? Earlier it was a different value. Now it is a different because it is the actual value. So this is the difference. So you can easily tell your student to relate the data with the experimental values. So they can easily correlate. So this is one way to get the data. Now another way, like how can we do that? Let us suppose I'll click on this and it will be deselected. And another way to find out the bond length, I'll tell you. Again, you will select this atom. Okay. Then control key ko press karna hai. Then you will select the other atom. Okay. So now let us, did you observe when I was selecting my atoms, this kind of, initially it was all frozen up. Once I selected, you can see this kind of, this bond length icon has been highlighted with question mark. So I will click on, I will display, and it will display the value on my particular structure also. So this is the one way, and the previous way also there. You can just simply click on the bond between your molecule and right click, and bond info will give you the data. Both way you can do. Okay. Another way to, this is one activity we have done, how to create our hydrogen molecule. Now the second step wahan par tha, how to calculate how to draw the water molecule. So now let's draw water molecule together. Now, I want to save this molecule. How to save this molecule? Here you can see, you will go to the file, you will export, you will click on the export. And here again, you can see, I told you there are different ways in which you can save your file. So JPG file is the format in which we can easily access our data. So I'll click on the JPG and it will save the molecule for me on my desktop. Okay, so let me, so I'll show you molecule at the end. Okay, so again, I have to close my screen. So I will show you molecule like we have already saved that molecule. So now this has been completed. Now I want to work in with another molecule. So what you can do again, you can select a new, create a new molecule file, or you can close like this also. It will ask you, molecule has changed. Do you want to save before closing? You can do that. Let us suppose I don't want to save it. So I'll click on no. So it has been frozen. Let me share again. Now, is it visible? Screen is visible. Okay, I think it's hanged in between. So what you can do, you can either, taking some time to close, I think it is hang in between. So can I close it? Let me show.
Ma'am, you're muted.
Please wait a second. There is some technical issues.
Sorry, everyone. Some technical error was there and I was dropped out from the meeting. So let me share my Argus Lab screen again. So okay. Is it visible now?
Yes.
Okay. So where were we? We have already built hydrogen molecule. So I want to create new molecule. Again, I will create new molecule window. This kind of window will come. We have already learned about this step. Now coming to the another property, I'll show you how to calculate the bond angle and other parameters. So let us suppose, again, I'll build a molecule here. So again, the same step we have to repeat. I'll drop my atom here. Okay. Now, let us suppose first I'll show you how to add hydrogen to any. Let us suppose you want your child to create some molecule and he doesn't know, he wants to add hydrogen to that particular molecule. So how to do that? So let us suppose this is simple molecule which I have added here. This is carbon molecule. You can see on the top, this is the add hydrogen. This is for erase hydrogen. So I'll add hydrogen. So see, you can see by default, I told you it is a carbon and it has taken it will by default, it will add the hydrogen. Okay. So, but we know, let us suppose I want a CH3. So anytime I can change the geometry. If I'll click on this atom. So here you can see, if I see, you can check, this is not my perfect molecule. So what I'll do, I want to erase some kind of atom. So I'll just select and delete. I'll use my delete key and I'll delete. Now let us suppose I want to change this atom to oxygen. So one way to do that, so how we'll do? So we will see, what I have done, this is another way you can select your molecule. I have used my mouse and I have selected that particular portion. So in that way, let us suppose I just want this to be changed. So I will deselect this. Okay. And I will change this atom to the oxygen. Now I want oxygen to be sp2 hybridized. It gives me full freedom to change my atom as per the even hybridization as per the molecule. So, okay. So I'll click and it will ask me whether you want an aromatic oxygen or in a non-aromatic setup. So I want to build water molecule. So I want non-aromatic. So I'll click on this. So it has taken a non-aromatic oxygen geometry here. So here you can see, but again, it is not a best fit structure. I told you we have to clean the structure and we will optimize our structure. So this way we have built. Now let me first clean my structure. I'll again click on this. Again, it will ask me to save my molecule. I'll simply write water molecule here. I'll save. Now here you can see it has compressed a little bit. Again, the same explanation which I gave you. Now I want to do certain kind of calculation. Now there is one more way which you can do the calculation. Just if you want to do the calculation, you can just simply click on this kind of icon also. And I'll go to the optimized geometry. I'll optimize my structure and I'll pick PM3. I told you the basic simple basis set to be used for these molecule will be PM3. Now I will check all these parameters which I want. Now I'll click on the OK tab. So I have done geometry optimization here. So now let me, I want to see the bond information or bond molecule. The same way you can do, you can simply click, you can see the bond info of what kind of atom are there and other things, length you can calculate. In this way, you can easily find out. Now I want to find out the bond angle. Initially, when I selected the bond and bond length in the hydrogen molecule, this kind of length, this icon got selected. Now see, when I want to calculate the bond angle, so this will be selected as per the choice of atoms. When I'm selecting, let me select the atoms here. See, can you see? ठीक है, तो यहाँ पे select हो गया. Now I'll click on this. It will give me my bond angle. So this way we can do the simple bond angle calculation also. So this way we can complete, this way we can find out the bond angle, what will be the bond angle. Even if my system has some dihedral angle, it will give me, display the torsional angle also. It will show me the XYZ axis. Now, let me show you how you can rotate your molecule. So here you can see all these icons. You can translate your molecule. Molecule will translate. So I have selected and I can easily translate all these movement I'm using my left click mouse. Okay. Then this is for the rotation. You can rotate your molecule. And again, all these you can align, zoom for left mouse button. And this is rotation about Z axis as per the molecule. And these features we have already explored. This is for the automatic bond on. This is required whenever you want to build any atom. You have to make sure it is on. अगर ये off होगा तो bond formation नहीं होगा. तो आपको one time select करना है, click करना है. Okay. So we have covered all these things. Now let us suppose in the same atom I want to change and I want to see. I want to make it H2S. So what I have to do, I have to simply select this and I'll change my atom. I'll see. I will go to the periodic table because atom sulfur was not listed there. So from here I can pick my sulfur atom. So there is the sulfur. So we can make the selection here. So let us suppose I have selected. So this is the sulfur. So again, this is not the perfect geometry. I have to clean it. I will clean my structure. Now you can see this is the perfect geometry. So this way you can see how these are molecule. You can make it selenium. Then you can calculate the dipole moment of your molecule. I show you in the previous calculation. This is your this is for the water molecule. So here you can see we have run the calculation for water molecule. This is for, we'll find out from here. So this way you can see your output file also and calculate the data. See the data. These are the heat of formation in kilocal per mole. So here you can easily see the values. So let me close these windows for the time being. So yes, sir, you have question? So you can unmute your, yes.
Ma'am, good evening, ma'am. Ma'am, here after cleaning, we don't need to optimize it.
No, sir, you have to optimize it. For better result, you have to optimize. Otherwise, you will
Every
have
time.
absurd results, sir. Yes.
Okay, thank you.
You have to do. The step are that you build your molecule, clean the structure, optimize structure, then you have good result. This way you have to proceed. I
This is
have
the
listed
steps.
all, yes,
Ah,
sir,
yes.
I have listed all those steps in my PPT. I'll share with you.
Okay.
You can go through that.
Thank
Okay.
you.
So we have done how to calculate bond length, bond angle. We have performed this work. Now I will show you how to calculate the bond length in the hydrocarbons. I'll take alkane, alkene, and alkyne with you. Okay. So again, I will take a new library. I'll make a new molecule here. So now try to make we will make ethane first. Okay. So here again, I'll click on this. I'll drop my atom. Second atom I'll drop here. By default, it will always be carbon atom. So now I have to make bond between them. What I will do, I'll click on automatic bond on. I'll press left click on first atom, left click on the second atom, the bond will be formed. Now next step, I have to add hydrogen. I'll go to add hydrogen. It will add hydrogen. See how it is not the good structure. The bond lengths are so much elongated. So what we will do again, we will clean the geometry. So we will clean the geometry. I'll make it ethane and I'll save. Now here you can see it has come in close proximity with the true values, but still it is not the perfect structure. It is not the most stable structure. So for that, we have to run the calculation. So this way, see, Earlier, I was clicking on this calculation. So both ways you can run the calculation. By clicking on this icon, this kind of dialog box will come. Again, you can calculate here. So let me check the bond order here. Some Mulligan charges I want to calculate, and I'll click on the OK. So it has run the calculation for me. I have got the data here now. So now let me check my values here. So you can click on this tab. So here you can see, you can see all the carbon and that hydrogen which are there. The atomic information is there. Okay. So next is that we have calculated the bond. It is giving me the, see, bond angles are also calculated here. So how to read this? For that, you have to label your atom. For that, you have to label your atom because it is, you have to label by doing on the, go to the label setting and you will label your atom. Then you can easily read out. It is between C1, C2, C1, carbon C1, CH3. So like this, you will read your data here. Okay. So this way you can see again, you can find out the heat of formation. Okay. So this way, and this is the final geometry energy. This way. So it is basically showing us all the steps because it is a computational molecular modeling software. It is running large number of iteration to calculate this. So all those, don't get confused what we are getting in the output file. It is doing all the iteration to reach to the final step. Basically, we have to converge our molecule. So we have done. Now I will change this molecule to another molecule, means just to save our time. So what I will do, let me just click on this atom, on the bond, bond between carbon, and right click, I'll make it double bond. Okay, so because I want to build now the alkene here. Okay, ethene I will make. So we know ethene, we have 2 hydrogen atoms. So we have to delete the hydrogen atom. So I'm deleting hydrogen atom. So again, this is not the good structure. I have to clean my structure here. So I'll clean my structure. Okay. So what is the problem here? Can anyone tell why still it is not the good structure? Because we have not changed the geometry of my carbon. See? We have
hybridization.
Yes, so hybridized. It is still sp3, and I told you that this is the way in which you can make your student learn that they have chose the wrong geometry. So this way they learn about the hybridization also. So I'll make it sp2 and it is a non-aromatic. See, again for this also we have to change. It is sp2. Okay, so now I'll perform clean geometry. See, now it is in align. It has aligned perfectly. Again, I will run my calculation. I can do the calculation run, and this way we can complete. Now coming to the last structure, that is we have to make it now a triple bond. So again, I will click on this and I'll make it triple bond here only. Now again, if I'll clean the geometry, the bond, the hydrogen atom will not be in perfect alignment. So we will do it initially only. I'll change the hybridization here. It is, see, it is sp2. I'll make it sp. Okay. So we can do it here. We can take from the periodic table. So it will be sp now. Because वो जो dialog box में आता है ना, वो जो frequently use हुए होते हैं उन्हीं को list करता है. तो आपको अगर कोई नहीं मिल रहा है, you are not able to find any particular, you go to periodic table. You can easily get. See, now I will clean. Now I have to erase. So now just look at this. I will clean the geometry, and it is a linear structure, which is a ethyne molecule. So this way we have done. And how to calculate the bond order? Again, we will click. I can just do one way. I can click on this. It will be highlighted. It will list the value for me. It is 2.4. Or we can just, I can click on this particular and I can get the bond info. And this way, sorry, it was wrongly. It was of previous. So this way I can click on the, let me deselect it. Okay, so this way we can fetch the data here from the bond info, we can calculate. Now let me show you one thing. So what we have done so far, we have calculated, we have find out how to build atoms, change the bond length, how to find the bond length. Even we can find out the bond order also. So let me show you how to get the bond order so that you can easily relate bond length and bond order. I'll just quickly draw again one molecule with you. So let me, this molecule is with me. This random value, I'm just giving it. So this way. So let me just. So we have bond order from their output file we can generate, or I can just simply click on this. Sorry. I can simply click on my bond. See, we have to deselect this arrow, otherwise every time it will build the atom here. So you can see the bond info. We can set the bond distance. You can specify the order. You can find out whether it is a bond order is what. You can see it is 1. अगर यहाँ पे मैंने इथीन पे किया होता तो bond order मुझे 2 दिखाता. Now this way I can easily bond info. We can find out. See, this is the dialog box. You can easily find out the length. Okay, and from the output file we can find out the bond order. So let me label this molecule. I'll label this atom. So I have labeled C1, C2. So it will be easy when you will read your output file. You can easily see what is C1, what is C2. So here you can see the bond length between C1 and C2 is 1.51. Okay. So this is the value 1.51. So this way we can easily find out. So different values, different data are calculated here. So even the bond angle, the dihydrogen, we can get the detailed analysis, how many bonds are there, different bond angles are there. So we can easily do that. So this way we can easily, even dihedral angle data would be there. Okay. So we have, so let me show you one assignment that you can share. So this way we have completed. Let me make a benzene ring also for you. So it will be easier. We can easily take the benzene ring from here. See, this is the benzene ring. How to get rid of this? You will just click left click mouse. It will be vanished. Now I want to create my benzene molecule on my own. So let me drop again the atom here. Okay. So let me drop the atoms. Okay. So now I have dropped 6 carbon atoms here. Now I'll make the bond here. So what I'll do, I'll select this. Okay. Now I will clean my structure again. So I will add a hydrogen atom first. C. Okay. Now I will clean my structure. I have to make other file name. C. Compressed has come to the close proximity. But now I want to make benzene here. So what I have to do, I have to make alternate double bonds. So I'll make this bond double. I'll make this bond double here. I'll make this bond double here. Okay. But what is wrong here? We have not changed the hybridization. So we have to do it. So what I will do, because it has taken how many hydrogen atom it has taken as per the sp3 carbon. And we know it is not sp3 carbon. So first we have to, I can just simply, what we can do, I'll delete all my atoms here. All the hydrogen atoms I'll delete here. Okay. Okay. And one by one, I can change my symmetry here. I can change the atom. I'll change it. Okay. It is an aromatic. Okay. See, it has changed now. Now I will add hydrogen here and see how many hydrogen it will take now. See, it has taken as per the hybridization. Now it has not taken randomly any extra hydrogen. So as per the hybridization, it has taken atom. Now let me clean my structure. See how beautifully it has come out. So this way you can easily do. Now let me go back to my presentation and show you what kind of assignment you can assign and you can do, ask your children to do. Let me share my PPT once again with you all. So we have very short time. Let me share just quickly. I want to show you something. Is it visible? My screen is visible. My PPT is there.
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, yes, ma'am.
Okay. So see. So here what I want to show you, see this kind of exercise you can assign to your students. See, they can build, you can ask them what are the key takeaways. You can ask your student to build these molecule and assign the bond angle. See how beautifully they can do that with all the pictures and all everything. And they can assign, you can ask them to calculate the bond length and bond order. They can interpret higher the bond length, shorter will be the bond order. And they can build their this kind of molecule on their own. So this way you can complete. And one more assignment that I want to show, I want to show one thing before we end this meeting. Here, I show you the molecule, how you can save your molecule. So these are the output file here. So can you see this screen here?
Where
is
is the
a
output
benzene.
file, ma'am?
The benzene molecule, can you see here on the screen?
Yes, ma'am.
Okay.
Yes, ma'am. Yes,
So,
ma'am.
okay.
Methyl
So,
benzene.
no, this molecule. This is the export file which I have exported. Can you see this screen hydrogen molecule? Is it visible?
Yes, ma'am.
JPG
No,
file
only-
of hydrogen molecule. Is it visible? JPG file of hydrogen molecule.
No, ma'am.
No, ma'am. No, ma'am.
No, let
Only
me
with
share.
methyl benzene, ma'am.
Okay, okay. See this file. See, this is the export file.
Now we
When we draw the hydrogen molecule, this kind of output file has been created in my desktop. So this is the file. You can simply, what you can do, you can copy here and paste any document where you want to and crop the structure. Okay. So this way you can easily take the structure. You can easily take the, and one more assignment, I want to share it with you that you can assign to your students. Let me, this kind of, see. Is it visible?
Not
No.
yet, ma'am. It is
No.
showing hydrogen
See,
molecule.
see, now see this.
Yes,
Ah,
ma'am.
Is
yes,
it visible
project.
now? Okay,
Yes, ma'am,
so this
project.
kind of assignment you can give to your students. They can complete, they can paste the optimized structure here. They can report bond length, bond order, heat of formation using the Argus lab. And they can they can pen down their result, what kind of observation they have observed here. Okay, and they have written, they have write their interpretation also. So in this way, they can easily complete these kind of small activities and they will find it fascinating because they can visualize all those molecules on their own. So now, if you have any query, we can take the query if you want.
Ma'am,
Yes.
ma'am, Pankaj Sala here. Ma'am, this you told earlier that it is helpful for the research purpose also.
Yes.
So easily it can be done from here.
Yes,
Can
sir.
you can
Yes,
you
sir.
showcase any item which is helpful?
Yes,
Because
sir.
I am pursuing my PhD.
Okay, sir. Sir, I will show you. Let me share the Argus lab again. Okay. Sir, in this, all these, you can easily run you can calculate you can find out the charge transfer also, like what kind of charge transfer has been taken a place. So when you see these kind of surfaces are there, make surfaces.
Yes.
Okay.
Yes, ma'am.
So it give you an option to create the electron charge density area also. So it is, I can't go much into detail because
No,
the
ma'am.
other
Yes.
participant will not, so this way, So you can easily go through, and other calculations are also there. If you can see UV visible spectra,
yes,
you
ma'am,
can
yes.
run for your structure.
Spectroscopy calculations are also possible, no?
Yes, yes, sir.
Thank
And
you.
for
Yes,
that, you can go to the help tab, sir. There is a tutorial. So
Okay.
step by step, everything is listed, like what kind of, like for different molecules, they have given the whole entire steps are there. So you can do that, because for today's session, we are restricting ourselves
Yes.
to the
Yes,
school
ma'am. Thank you.
system, so that student can easily can use that. And
Thank you so
can,
much, ma'am. Thank you
yes.
so much.
So other parameters are also there. Any other query?
Ma'am, please one doubt, ma'am.
Yes, yes.
Ma'am, used the Argus lab, draw the any molecule structure and the other properties.
Sir, pardon, any molecule, yes, we can build any molecule.
Ma'am, yeah, draw the structure, any draw the structure of molecules, another properties, for example, bond length, bond order, then hybridization.
Yes, sir. Yes, sir. We can do that.
Thank you, ma'am. Thank you, ma'am.
Sir, it depends. If you are taking a small molecule, it will run and show the result faster. If you
Okay,
have a
ma'am.
bigger and complex molecule, it will take some time. For
Okay, ma'am.
that, you have to change your basis set also. That I told in the beginning only, that for small calculation, the basis set which I chose, they are perfect. But as we go beyond certain number of atoms, like if I take some bigger molecule, then we have to change the setting accordingly. But as per our school, like if you want to show, even we can show the cyclohexane bond and chair structure, because there is an inbuilt structure I show you, inbuilt library, where there is a cyclohexane is there. So you can easily show the transition. You can ask your student to build and show the transition and alignment of atoms there, hydrogen atoms. This. Yes, sir. Anil, sir. Yes, you can ask.
Hello, madam.
Yes, sir.
Okay, madam, regarding this, regarding downloading that particular app,
Sir, I
faced.
will share. Yes, sir. I will share the
No, madam,
that
I've
particular.
already
You-
downloaded that one.
Yes, sir. Yes,
So
sir.
while running that particular exe file, so it had mentioned that it is not what to say, some
Insecure.
error, yeah, insecure.
Sir, accept those, accept that and go ahead. There is no issue. Because this particular software has been used by many institutes, so it is not an any threat to any system, I can assure you.
Okay, ma'am.
So you can click on the insecure file, it pop up that particular message, go with
Okay.
that and just you can use it, no issue.
Okay, then, ma'am. Thank you, ma'am.
I will share that how to download Argus Lab again in SRG WhatsApp group. So even if someone has any issue, you can see while downloading the Argus Lab, I have shown all those steps. That one you mentioned, insecure file, that window, that particular message generally comes. You have to accept and go beyond, take another step then.
Okay, ma'am.